Yo, what's good? Today, we're going to be learning about the most exciting thing of all, waves. Now, we're talking about science waves.
Yes, science!
I'm not talking about the hairstyle waves, waving at your friends, or the song Waves by Dean Lewis, alright? We're talking about transverse waves and longitudinal waves. Now, you might be thinking to yourself, what do those words mean? And by the end of this video, you will know a bit about what those words mean, alright? So, yeah, we'll just get right into it by explaining longitudinal waves. Now, I want to talk about longitudinal waves, alright? What are they? Who knows? That was a rhetorical question. I know, and soon you will know, alright? So, essentially, all a longitudinal wave is it's just a wave that vibrates parallel to the direction of wave travel, alright? So if the wave is moving left, it will move both left and right because it moves back and forth, alright? So that's all it is. It's so simple to get your head around, alright? There will be areas of compression, which is where the vibrations are closer together, and areas of rarefaction, or however you say that word, which is where the vibrations are further apart. Alright, examples of a longitudinal wave is sound. So now you probably wish they didn't exist, so you don't have to listen to me waffle about waves, but they do, so that's unfortunate. And how if you want to see how a longitudinal wave works, all you need to do, you get a slinky, stretch it out a bit, and you just like move it back and forth, and you'll just see a bit traveling through. It's that simple. Right, so a transverse wave, right? If a longitudinal wave moves parallel to the wave direct travel, all right, I'll let you guess what a transverse wave does. It moves perpendicular, because it's the opposite of parallel. So if you guessed that, give yourself a pat on the back. You're a smart person. All right. So essentially, it just moves perpendicular to the direction of wave travel. So like a ripple in water, yeah. So that'll be moving up and down, but it'll also be like moving out. Um, and they have peaks or crests. It doesn't really matter what you refer to them as as long as you know they're the top. And then it also has dips or troughs, which you're probably better off saying troughs. Dips isn't very scientific. And yeah, if you want to know the wavelength, you just measure the distance between two adjacent troughs or two adjacent peaks. So yeah, that's essentially all a transverse wave is. So the difference is that transverse waves are perpendicular to the direction of wave travel, and longitudinal waves are parallel. So yeah, now you hopefully know what waves are. And yeah, I hope you learned something today. Thank you.